All right, you asked for a quick video about section 10.3, so let me go ahead and fill in a couple of the gaps. And remember that section 10.3 are the problems where they asked us to solve quadratic equations by graphing. So we're solving by graphing. Remember that we can always make the equation equal to 0, and that's our biggest trick, is to make the y value be 0, or to remember that y and 0 can be interchanged. When we do this, we expect three possible things to happen. The first is that the graph could possibly cross the x-axis in one spot. This would give us one solution that actually functions as a double root. So like we have here in this first picture, that we have x equal to 1. That comes from, remember we talked about that double root before when we were doing factoring. If it's because we would have x minus 1 times x minus 1, or we might have been given the question x minus 1, the quantity squared. Either way, this is the picture that happens when we get that double root idea. Or the most common version is that we get two zeros, or two roots, two solutions. And that happens at a problem like this when we see the graph crossing the x-axis in two spots. We would just list it as x equal to 0, x equal to 2. If we were going to factor, we would find that x minus 0, x minus 2 is where our factoring came from, or x times x minus 2. So again, I'm just looking for these two solutions. So we're just simply going to look at the graph and read those solutions, if we can. The last type of graph is one that doesn't cross the x-axis, right? No points here across the x-axis. So we say that we have no real solutions. They're actually imaginary, and so that's why we would say no real solutions, as opposed to using the empty set. So one solution, or a double root, two possible solutions, or no real solutions are our possibilities. Now, if we're asked to solve the equation by graphing, we have some basic steps. The first is that we're going to make sure that the equation is equal to 0. Step 2 is to graph, right? Find the vertex and a few points. Step 3 is to look at your graph and decide or find where the graph crosses the x-axis. And then we can check these by plugging them in and making sure they make the equation equal to 0. So I went through and I used my vertex form, x equals negative b over 2a. I used that to find my vertex, so the opposite of b over 2 times a. Oh, I didn't point it out, but I did it over here, that I subtracted 3 because I have to make sure I have it set equal to 0 first. So I've got it set equal to 0, then I went to my axis of symmetry. I found my axis of symmetry to be positive 1, so that's why I filled in my vertex of 1, or vertex x value of 1, and that's why I drew my vertical line for my axis of symmetry. Then I went through and I found my y value for my vertex by plugging that axis of symmetry in. So I plugged it in and I solved, and I got that the y value is negative 4. So that's this point down here. Even my graph got a little sloppy here. And then I used my table of values to plot some more points. And I decided from 1 I would count down, 0, negative 1, negative 2. Remember that vertex is always that symmetry point, that point of symmetry. So I could have counted up and done 2, 3, and 4 to find those same values. And again, I just plugged them in. I did the negative 1 down here so I could show it to you. But you could plug all of those values in to get all of the different possible answers. So I plugged it in. I had some more points, so I plotted them. Don't forget about that y-intercept. I didn't really do any work to get that 0, negative 3 point. This is the point I did some work for, and some more work for these. I sketched my graph, and then I simply looked at it to find my roots or my zeros. Remember, those two words are interchangeable. Crosses at negative 1, so my first one is that x equals negative 1. The parabola crosses the x-axis at positive 3, so there's my second root. A degree of 2, I would expect 2 answers, and I got them. I can always check by plugging those values back in. So when I plug -1 in, I should get a 0 out. And when I plug 3 in, I should get a 0 out. So y equals 3 squared minus 2 times 3 minus 3. That's where I'm plugging into the original that's set equal to 0. 9 minus 6 minus 3, 3 minus 3. Yep, I get a 0. So I've done it correctly. If you'd like to go ahead and work on the next problems on the next page, I will go ahead and put an answer key up, but I'm not going to talk through those.